Alright, so our ellipse, we're going to look at the geometric definition just like we did for our parabola. So ellipses are going to be the set of all points whose sum of the distances to two fixed points, and just like with our parabola, our fixed points are going to be our foci, is constant. So look on this first ellipse. Notice that they have D1 and D2 labeled. Basically, that's the distance that any point is from both of your foci. So what it's telling us is that if I were to take the sum, which is addition, whatever I get anywhere along this circle, or ellipse, I would have to get the same thing. Does that make sense? So basically, I can take any point here. I'm going to find my two distances and add them together, and I would get the same value for any given ellipse. Okay, yep. It's a K for constant.
I remember this slightly.
Constant is a C, but we have another C value, so that's why we use K. You learn.
Constant with a K sounds cooler.
Alright, so let's think back to our parabola. How many axes does our parabola have? One. And what does that axis do? Yes, but it's also the axis of symmetry, which means it does what? It cuts it in half. So our parabola can only be cut in half one way. How many ways can an ellipse be cut in half?
Like twice.
Two, which is why we have a major axis, which is going to be the longer of the two, and a minor axis, which is the shorter of the two. And your center is where those two things intersect. And we have two vertices, which are at the ends of your major axis. And then you also have two co-vertices, which are at the end of your minor axis. Yes? So those are going to be the things that we are looking for when we're finding information or graphing or doing different things with our ellipse. So remember that with all of our conic sections, we are going to have equations. And that's going to be the basis for a lot of the stuff that we do for them. So we need to have our equations written down. We have two types of ellipses. There's a horizontal ellipse, which is like what is shown. And there's also a vertical ellipse, which is basically like if it was rotated 90 degrees, it would be going up and down. Their standard form equations are very similar. The only difference is that your A value is bigger, so it's going to be horizontal if the bigger number is under your X, and it's going to be vertical if the bigger number is under your Y.
I've never understood ellipses, oh God.
So your center, again, remember, is the point that is in the middle of everything. Our major axis here is going left and right. Which means that our vertices are on the ends. So this is our major axis. What else does it tell us about our major axis?
Horizontal?
It is horizontal. What does it tell us in the instruction?
It's a length of 2A and 2B.
Yes, so the length of our major is 2A. So what does that mean the distance from one of our vertices to our center is? It's going to be just A. Likewise, our minor axis goes up and down, so that's where our co-vertices are. Which means that the length from a center to a co-vertice is what? B instead. Because it tells us that the length of our minor axis is 2E. So remember that we also have two foci. And it is important to note that your focus is not in the middle between your center and your vertex. So it's going to be a specific length of C to both sides. Now, what would happen if I made a triangle from my co-vertice to my focus?
It would be a triangle.
Yeah, but what kind of triangle?
Oh, right triangle.
It's specifically a right triangle. So what are the lengths of my two legs?
A and B.
Not A.
Or B and C.
B and C. So we know that if I add the lengths of my two legs, what does it equal? The hypotenuse squared.
Sure. Okay, I agree.
What about? So, do we see that I have a triangle here?
Yeah.
Okay, do we see that it's a right triangle?
Yes.
Do we see that because my focus on either side is the same distance, my bottom leg would be C, and because they have to be the same distance to my co-vertex, the right leg would have to be B. Agreed?
Agreed.
And then by our Pythagorean theorem, it tells us that if I take both of my legs and square them and add them together, it's going to equal our hypotenuse squared. Agreed? Yes. Now, and for us specifically, your hypotenuse is going to end up being the same distance as A. So this would end up being
Prove it.
the very long word. But it makes sense though, right? Because A is going to be our largest value, right? Because it's bigger than both C and B.
Yeah.
And your hypotenuse has to be your largest value because it's the distance between your other 2 points. So it makes sense that it would have to equal something that's bigger than B and C, and A is our biggest value. So this is going to be an important formula because we're going to have to use it depending on the information that we're given. So sometimes we're given B and C and we need to find A. Sometimes we're given A and B and we need to find C, and so forth. Yes? We're okay with that. Now, specifically here, what would have to happen to this ellipse in order for it to be a circle?
Somebody was
They would have to.
Squish it? Okay.
Yeah.
How so?
It is a circle.
Okay, it would have to be, it's not a circle. It would have to be squished together. So that means that my A value would have to be smaller, right? Specifically, what would our A value have to be?
equal to B.
It has to be equal to B. So whenever the distance between our vertices and our co-vertices to our center is the same, we end up with a circle instead. Okay with that? Which is why remember that your circle formula is x minus h squared plus y minus k squared equals r squared, right? It just equals a number. You should have learned that in geometry.
Oh.
And the reason that it equals r squared instead of 1 is basically they take, because a and b are equal, so if they were like 4, they just multiply everything by 4. And so it gets rid of your fractions and moves the 4 to the other side. But like I said, for the most part, we're not going to be dealing with a bunch of circles because they have a very similar pattern to our ellipses, and we should have seen circles in geometry.
You say so on the bottom of the fraction, the biggest number goes first.
No, the biggest number is A. So A is always bigger. So like on the first one, my bigger number is underneath my X, and so it would look like the one that I have down here. If my bigger number was under my Y, basically it would be flipped and look like an egg standing up. Because your Y is bigger, so it goes up and down. Alright, so let's look at some examples. So this one says, find the standard form of the equation of the ellipse having foci at 0, 4, and 4, 1, and a major axis of length 6. So what did we say that it's generally going to be helpful to do? Draw a picture. Okay. And it gives us 2 points for our foci. Where are those located?
0, 1, 4, 1.
Okay, so where is 0, 1 going to be?
In the center, 1 up.
Okay, so which axis is that on?
With friggin' minor pieces for the tiny one.
No, our foci have to be along the major axis.
Sorry, the y-axis.
And it's on our y-axis this
Yeah.
time. So, in which direction from that foci is my other foci? It's to the right. So, because our foci have to be along our major axis, what type of ellipse do I have here? It has to be horizontal.
I was going to say short.
Yes? Agreed? Which is helpful because now we know that my A value needs to be below which of my variables? Bx. So what are the 4 things that we need to find in order to be able to complete our equation? A, B, we don't need C. H, and K. So what can we find first? How do we find H, K? Correct. So remember, your center has to be the center of everything, which means that if you're given two foci, you're given two vertices, or you're given two co-vertices, then it has to be the midpoint of those two things.
Don't we have that?
We do. We're just not there yet. So what is our midpoint formula?
That's x1 plus x2 over 2.
So specifically in this case, what does it end up being?
2, 1.
Agreed.
Why does it need to be a big formula that was easy?
Because sometimes, like in this case, we had all whole numbers, so it's pretty easy to see. But like if I had like 2.7 and like 4.1, right? I don't know what the midpoint between those two things is off the top of my head. Like we would just use the formula then. So we know that we have x minus 2 squared plus y minus 1 squared. And now we need to find A and B. But do we know A or B?
We know A apparently.
We do know A apparently. What other piece of information do they give us? Our major axis. Now remind me, the length of our major axis equals what? 2A, right? Because the distance to one vertex is A. So if I had both of them, it would be 2A. But since they tell me that the length is 6, what do we know that A has to equal? 3. So what is going to go underneath my X?
9.
Okay.
Dang, I'm getting pretty good at this.
Okay, so then what are we left to find?
B squared. Okay.
B or B squared. So do they give us any information about our co-vertices or the length of our minor axis?
No.
No, but do they give us anything else? They give us our foci. And so what do our foci give us?
The length of C.
The length of C. So what is C in this case? It's going to be the distance from the center to one of your foci.
2.
Which would be 2.
So then you plug that into the Pythagorean theorem.
The theorem. So B squared plus C squared equals A squared. So we get B squared plus, you said that C was 2, so 2 squared is 4. And then A squared is 9. So we end up with that B equals the square root of 5. So if I square the square root of 5, what are we putting underneath? Just 5. And so that would be my answer. Questions on any of that? Yes. How did I get? Oh, because if I know that my center is at, we said 2, 1, yes? Then I know that if I go from 2, 1 to get to 4, 1, I've gone a distance of 2. Does that make sense? And again, if you didn't know what the distance was, we can always use our distance formula, but since everything is kind of lined up, we're basically just counting units. Other questions? Do we see where we got all the numbers and equations from? So let's look at an example where we graph it. So what might it be helpful to start with?
Probably the A and the B.
Maybe, but what does all of it kind of revolve around?
Oh.
H and K, which is the, not the vertex, the center in this case. So what is the center?
Negative.
-2, -2. Remember, we have to flip our sign for both of them. So if we graph that, we're in our third quadrant. Now, how far am I going to go from my center to get to my vertices? What variable is that? A.
So
And A is going to be the bigger number. So for us, that's going to be 9. But then remember that this is a squared, so it's 3. Likewise, our B value is going to be the smaller one, but this time we take the square root and we get 2. So since my A is underneath my X, we're going to go left and right 3 units.
1 negative 2 negative 5 negative.
And then since our B value is with our Y, we're going to go up and down 2. And then we just kind of connect it all together.
That was pretty easy. Why is that curve on the right side perfect?
It starts off better and then it's worse.
Yeah, it's like when you start drawing a horse and finish with sticks.
So, what would I do if they asked me to label or find our foci?
you could do
What do we need to find?
C.
Our C value. So, we would use our B squared plus C squared equals A squared. So, we would have 4 plus C squared equals 9. So, C equals the square root of 5. Again.
And then
So to find our foci, we're going to either add or subtract it to which value of our center? The X or the Y?
X.
The X, because we're horizontal this time, our foci have to be along our horizontal axis. So we would have negative 2 plus or minus the square root of 5, comma negative 2. So what is the square root of 5 approximately?
Well,
Plug it into it later.
1.75
What
or
is it?
something weird.
Not quite.
2.5.
Not quite.
Less than 5.
It is.
More than 0.
It is.
I'm right.
2.2.
It's like 2.23. So if I took 2.23 and I added that to negative 2, what would we get? So negative 2 plus 2.2 would just be 0.2 comma negative 2. And if I took negative 2 and I subtracted 2.2, we would get negative 4.2. So again, if I wanted to graph those, we would be at like 0.2, negative 2, and then like 4.2. You're either going to add and subtract your C value from your H or from your K. So like in this case, because we're horizontal, I'm going to take my H value and add or subtract C. If it was vertical, we would take it and add and subtract it from K instead. Other question? And we won't always have to find our foci. Like if they just asked you to graph it, you wouldn't have to find them. I just know there's a couple in your homework where they ask you to find them. So I just wanted to go over how to find them. Yes.
Why don't you do like diagonal?
So you can. There are rotated conic sections. That's what they're called is rotating, and you look at your axis of rotation. They're just not used a ton because for the most part, whenever you're dealing with things in the real world, you get to pick which way you're looking at the problem, right? So it's not like most of the real world is not on like a grid, unless you're talking about the Earth, but most of it's not on a grid. So then I can pick like which orientation I'm looking at it at. So I'm gonna pick something that lines up better. You can rotate them, and there is a section in our book that does it. We just don't get to it in here because we just don't have enough time.
Thank goodness.
And it doesn't come up as often as you would need it for us. If you get into like higher level engineering type classes, then you'll see it some. Alright. Let's look at another one. So we're graphing again. How is this one different though?
It looks like an equation.
It's in the last one was an equation as well.
It doesn't have any dividing.
It doesn't have any dividing. What's the problem with that?
It's stupid.
Do we know where our H and our K or our A and our B are?
No.
No, and we need to know those things in order to graph it, yeah? So what do we have to do?
Couldn't we change this into that equation?
Yeah, we're going to put it into the right form. So how did we do that with our parabolas? When we didn't have it in standard form and we wanted to put it in standard form, what did we have to do? So what's on top of each of our fractions? A squared, right? So if I have a perfect square, and I'm starting with something that's not a perfect square, how do we get to a perfect square? What's the process called? You do factor, but a specific type of factoring. We want to complete the square. Because we want to be able to factor them to perfect squares. So we have to pick numbers that make them perfect squares. So our first step is going to be just to write our x stuff together and our y stuff together. And then anything that doesn't have either one, I'm going to move to the other side. Are we all okay with that stuff? So far, so good? Basically, we have two problems here almost. Because I'm needing to complete the square for my x's. So I'm going to group those two together. And I also need to complete the square for my y's. So I'm going to group those two together. Now, what is the formula that we use to find the missing part for our completing the square? Has to do with your b value. Yep. So remember, it is b divided by 2 squared. So for our x values, what is our b? 6. So 6 divided by 2 gives us 3. 3 squared gives us 9. Now, the only problem with our y stuff is, remember, we're only allowed to complete the square if our a value is 1. So what do we need to do with that for? Factor it out. So now, what's our b value for our y? -2. So -2 divided by -2 is -1. -1 squared is 1. But am I allowed to just add 9 and 1 because we feel like it? You can either subtract it from the same side, right? But remember at the beginning, yeah, like I moved everything over this time because I don't want stuff that doesn't have x's or y's. So for this one, we're actually going to just add the same thing to the other side. So we're going to add what?
10,
Not quite.
9,
9 and what? Not quite.
4.
Yeah, we have to add 4. Because notice that that 4 that's on the outside of my parentheses applies to the 1 that's right here. So we didn't actually add 1, we added 4.
You took the 4 out.
Because I factored the 4 out. And my 1 is already in the parentheses. So it applies to the 1 as well. Does that make sense? So now our whole goal is to factor. And it should end up that they factor 2 perfect squares. Otherwise, we did something wrong. So what multiplies together to give us 9? That adds together to give us 6. 3 and 3. So we did our x's right. Then what factors together to give us, or multiplies together to give us 1? That adds together to give us -2. -1. Alright, so far so good. So then what is -9 plus 9 plus 4? 4. So is that my standard form? Not quite. We got the perfect squared part now, so that's good. But what does our formula equal for our other kind? For our standard form? It needs to equal 1. So what do we want to do? We just want to divide everything by 4. And that's also how we're going to end up with the fractions over here on the left. Because I'm just going to divide each of my pieces by 4. So notice on our first one, we just get divided by 4. On our second one, what's going to be in my denominator? Just 1. Because I already have a 4 there. So 4 divided by 4 gives us 1. So now can we graph that? We should be able to. So where's our center at this time?
-3 and 4.
Mm-hmm. And then how far left and right am I going to go? Not quite. 2. Because remember, a is the square root of whatever number's there. So I'm going to go left and right 2. And then how far are we going to go up and down? Just 1, because the square root of 1 is still 1.
Wait, how do you figure out to get 2?
So remember that this is a squared. So a is going to equal 2. So end up with a flip. Yay. So questions on how we got any of that stuff? We just have one last example. Basically, it's going the opposite way. If they give us a graph, then we need to find the equation. Again, kind of for all of these, like what's the easiest spot to start with? H and K, which is our center. So for this graph, where is our center? 0, 0. Well, that makes our life easier. So we would have x minus 0 quantity squared plus y minus 0 quantity squared. Now for this one, which one of my variables, x or y, is my a going to be underneath?
It's going to be under the y.
It's going to be under the y this time because notice that it is taller than it is y. Do we know what our a value is? So remember that the length of the entire major axis is what? 2a. And the distance from here to here is 9. So the whole distance would be 18. So a equals 9. So what's going to go underneath my y squared? 81. Now, what is our b value? The distance from the center to the, not quite, to the co-vertices. Well, where are co-vertices this time?
Or 5.
A little bit, well, these
Or
go by
6.
2s. So it's going to be kind of hard to see, right? Because it's not, one, we're going by twos, which makes it harder. And then two, it's not on any, like, exact line. So do we have any other information that we could use instead?
We have our
We have our foci, which gives us which value?
C.
Our C value, right? So again, we could use our B squared plus C squared equals A squared formula. What is our C value going to be? 7. So C squared would be 49. So is B squared equals 32. So that's what would go underneath my X. And that's my answer. And again, if you needed, or like they asked for the decimal approximation, you would just figure out like what is the square root of 32, and then you would have that decimal, the negative and the positive of it for your X values. Questions on that?